Hi friends. So welcome to lesson 18. So today is our new chapter, okay, chapter 3, which is properties of circles. Okay, so before that, let's discuss previous lessons homework first. Okay, so this was our previous lessons homework. So let's discuss a little bit. Right, so this unit 5B, okay, this is Singyi's work, all right, from year 10A. I will mark question 44 first. Okay, question 44 is about trigonometry. All right, let's look at 44A. Okay, you are going to calculate angle ABP. Angle ABP is here. This is a 90 degree, okay? This is a 90 degree triangle, okay? So, you don't need to do this long to find the answer, even though the answer is correct, but I still accept, of course, right? We can actually use just SOH, S-O-H, okay? Sine opposite, sine ABP equals to opposite 3.73 over 5.47, and you will still get the answer after you inverse the sign. Okay, you will still get the same answer. Alright, so 43.0, take the answer together, okay? And then for part B, we use cosine rule to get the answer. Okay, this is cosine rule, very good. The answer is 2.50 km. This one must be in 3 significant figure. Please double check your work again. Okay, and for C part 1, this is how Singyi did it. It's 180 plus 65, which is 245, okay? I think this is how she did it. This is 65, okay? So this will form an alternate angle here, which is 65 over here. So the angle, the bearing that you're gonna find is the whole thing until here, which includes 180 and the 65. So 180 plus 65. Okay, also can. Or if you use another method, okay, if you use alternate angle over here, 25 here is also 25. So you use 270 like this, you minus 25, you will get the bearing. 270 minus 25, you will still get the answer 245. Okay, and then for C part 2, okay, so the question say it's the lighthouse is at A here. The lighthouse, this is the lighthouse. The height of the lighthouse is 30 meter. Okay, and your boat is here. Okay, this is A. The lighthouse and the boat basically are on the sea. Okay, and 100 meter away, okay, the boat away from A, so you form a 90 degree. And the angle of depression you're looking for is this angle over here. Okay, this angle over here. So what Singyi did here is finding this angle here and then use 90, or she actually used 180 the whole thing to minus, or you can straight away 90 minus 73.30075 also can, because this is 90 degree. Or another way of doing this is alternate angle. So basically this is the angle that you're gonna find. Okay, you can use tan. Okay, 30 over 100. You will get the answer straight away. Okay, so 3 significant figures supposed to be 16.7 degree. Okay, so this is the answer, right? Okay, please tick your answer. Okay, question number 9A. 9A is under figure A here. Okay, so this is the answer. You rotate 4 times. It's an order 4, right? You rotate 4 times, it will be here, here, and here. Okay, the hint is, okay, first you remember this square, the shaded one, and then you rotate this figure 90 degree, and then remember this is your first second. So when you rotate your book or this paper, this will be your first and second, so you shade the second one. And then when you rotate again, this will be your first and second, so you're gonna shade the second one. And when you rotate another 90 degree, this will be your first and second, you're gonna shade the second one. Okay, so altogether there are 4. Alright, okay, so part B here, shade one more square so that the completed square grid has one line of symmetry. Okay, the one line of symmetry, the symmetry is here. So where you're gonna shade is over here. Okay? Okay, so 10A, okay, I think this one I don't need to explain anymore. We learned this in previous lessons already. So this is 6 planes of symmetry. Please take your answer. And number 2A, one line of symmetry is A and E. Okay, A and your E. This is one line of symmetry. And rotational symmetry of order is B, C, D, F, the rest of them. Okay, so please take your answer. So now let's go to this new topic over here. Okay, so this chapter is about properties of circles. But before that, I want you to understand certain terms, okay, of a circle. Okay, I know some of you already know, but please bear in mind, you have to remember all the words here. Okay, you might already know, but I want you guys to still copy down into your notebook. Okay, right, so parts of the circles, the thing that you need to know about part of a circle is we know that this is center. Okay, this is center. Okay, so center I don't need to write. And the next thing you need to know is your circumference. Circumference is this. This length of this circle, this one we call circumference. Okay, can you repeat after me? Circumference. Again, circumference. Okay, very good. So next thing you need to know is radius. Okay, this is your radius. Okay, the length that is from the center to the circumference is radius. So this is radius, 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 radius. Okay, as long as it touch from center to the circumference, we call radius. Okay, so next one is diameter. This is diameter. Okay, the red line over here is diameter. So one circumference, if the line from one circumference touch the other end of the circumference, we call diameter. And this diameter actually divides this circle into half. Okay, into half. This one is a semicircle and another one is a semicircle. Any diameter will cut a circle into half. Okay, remember that. And the diameter must pass through the center. Okay, one circumference touch at the other end of the circumference, passing through the center, only called diameter. Okay, what if a line that touch one circumference to the other circumference, but the line doesn't pass through center? It's called chord. This is chord. Okay, the green line we call chord. Okay, one line, one point on circumference touch the other. The end of the another circumference we call chord if the line doesn't pass through the center. Okay, and then I want you to know about this also. This one may be new to you. This line here, when this line touch, okay, at a point on the circumference outside, not inside the circle, outside the circle, touch only this one point here, we call tangent. Okay, this is called tangent. Okay, so this line touch only one point outside the circle. Okay, when it touches the circumference, we call tangent. Okay, and one last one. You look at the chord. If we have a chord here, this chord actually divides into a small segment and a big segment. Okay, this chord cuts, okay, this circle into segments. Okay, this one we call minor segment. Minor segment. Okay, and the bigger segment will be the other one lah, like this. Okay, this chord, this one we call major segment. So chord cuts into major segment and minor segment. Okay, but diameter cuts the circle into half, into two semicircles. Okay? Okay, so this is the part of the circle that you need to remember, and you please write it down. Okay? Alright, so just now was the part of the circle that you need to know. Okay, the part of the circle you need to know because when I explain circle theorems, there's terms that you need to know what is that. Okay, you need to know what is circumference, you need to know what is center, radius, diameter, chord, tangent, and even segments. Okay, so this topic is all about the properties of the circle, or another word for that is circle theorems. They are the same as properties of circles. Okay, it's the same thing. Right? But when I write here, I write circle theorems. Okay, there are 9 theorems altogether. Okay, but we will go through these one by one. Okay, so after you write down the parts of the circles just now, your first page will be all your circle theorems, and then your next page will start with try it 1 and all the exercises. Okay, so you leave 9 circles blank first. Okay, we will go through one by one. Okay, for today's lesson, I will go through only the first theorem. Okay, so you draw these 9 circles, but then you fill in the first one. Okay, theorem 1 is perpendicular bisector of chord passes through center. Alright, you write down this one on your notebook. So the first theorem is perpendicular bisector of chord passes through center. Okay, I'll explain one by one here. Perpendicular means 90 degree. Okay, bisector means the line that is cutting a line into half. Okay, into half. Basically, this 90 degree line is passing through another line that cut into half. Okay, so it says here perpendicular bisector of chord. Okay, meaning to say that this line passing through this chord, okay, passing this line is called perpendicular bisector, passing through this chord, and it divides into half. Okay, that's why it's called bisector. Bisector means cut into half lah, huh? Passes through center. So this line, when it passes through a center, it will become a 90 degree and cut into half. Or you can say that this chord, and if you have a perpendicular bisector line, right? Okay, if this line cuts this chord into half, this line will pass through the center. Okay, so this is your first theorem. Perpendicular bisector of chord passes through center. Do you need to memorize? Yes, you need to memorize. That's why we will go through theorem one by one. For today, you remember this, the first theorem. Okay, why do you need to memorize? Because some questions they will ask you for the reason. So when they ask you for the reason, you need to state the reason by stating the theorem out. Okay, you must state it. What is actually the reason because of which theorem? Okay, so this one is perpendicular bisector of chord passes through center. So I want you to visualize this one. Okay, you take a look at the perpendicular bisector, this line, and this chord. Okay, this chord. Look at what happened. Okay, it's always 90 degree and it's always cut into half. Okay, it's always bisector. And that line, the perpendicular bisector, is always passing through the center and it divides this chord into half. Okay, so no matter how I do it, I move my chord, okay, and this perpendicular bisector will always cut into half and is always 90 degree. Okay? Okay, so let's go to trait number 1. Okay, in the diagram, M is midpoint of the chord. Okay, chord, you know it's chord already now. And HK is the perpendicular bisector. Okay, so when they say this is perpendicular bisector of CD, which is chord, so we confirm that, know that this HK is passing through a center. Okay, it's passing through the center of the circle. Okay, so CD equals to 30 cm. So if C to D is 30 cm, so meaning to say that CM will be 15. Okay, will be 15 and MD will be 15. Half lah, huh? So 15, 15. MK equals to 9. So MK is this 9 cm. Okay, so find the radius of a circle. Okay, so maybe the only radius that you see is this one or this one. Okay, but then if we want to find the radius, it's best that we can see the radius is not only that 2 lines that I drew just now, it's also this one. Okay, maybe I can zoom in. Okay, so this is the radius that we want to find. radius r. Okay, so we can see here is a 90-degree triangle. Okay, this is r radius, and this length over here will be your radius. Radius is this whole length, radius minus 9. Okay, why? Because this is your r radius minus this 9 over here will be this one left. So r minus 9 equals to this. Okay, so if I were to redraw this again, okay, O is center. Okay, this will be your 90-degree. O, M, and C. This is your R. This is R minus 9. And then this is 15. Okay? So now we want to find R. This is a right angle triangle. So whenever we have right angle triangle, we can always use Pythagoras or SOHCAHTOA. SOHCAHTOA involves angle. Here, they don't ask any angle. You don't need to find angle, so you use Pythagoras theorem. So Pythagoras theorem is this r square equals to r minus 9 bracket square plus 15 square. Okay, this is your C, this is your A, this is your B. A square plus B square equals to C square. Okay, this is how it works. Okay, so we expand this one, r minus 9, and then 15 square is 225. This one expand. Okay, so r square and r square no more, because this r square, if you move to the other side, minus r square becomes 0, by the way. And then I move this negative 9r minus 9r to the other side, become plus, so it's 18r, 225. So r is plus 81. So 225 plus 81 is 306 over 18 equals to 17 cm. Okay, so this is the answer for your R. So try 2 here. In the diagram, A, B, and CD are two parallel chords of a circle. Okay, it's a parallel, they are both parallel lines. If AB is 24, okay, if AB is 24, meaning to say that, okay, the theorem 1 tells us that if it's 90 degree, okay, if it's 90 degree cut through the chord, it will divide into 2. So this will be 12, this will be also 12. This CD is 16, so if it's 16, then this one will be 8, this one will be 8. OM is 5, so your 5 here is this. This whole thing, this only, only this OM, short one, 5. Find the radius of the circle. Okay, allow me to zoom in. Okay, so radius, your radius line can be anywhere, here, 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 but if you write, if you draw the radius line over there, no use, right? Okay, so what if I draw my radius line here? Now got use already lah, If I draw my line here, it means that there is a right angle triangle here. See, 90 degree right angle triangle, OMB, OMB, okay? So I'm gonna draw out the triangle OMB, okay, which this one is 5, this one is 12. Okay, so OB is your radius, right? This is your radius basically. OB is your radius. So to find that radius, what we do? we use Pythagoras theorem. So r squared equals to 5 squared plus 12 squared. So r is square root of 5 squared plus 12 squared. So your r is 13. Okay, so this is your answer for part A. Now part B, the distance between M and N. Okay, now we have our radius already, which is 13. We found it already. Now we want to find M to N. Okay, now I zoom in again. How do you find MN? MN here. Only this short one. How? We have 5. Okay, we have 5. If you want this short one M to N here, what I'm gonna do is I'm gonna find ON and then minus the 5. Okay, O to N, I minus 5, then I will get MN. Okay, but to find that O to N, okay, I'm gonna draw another 90-degree triangle. Okay, here. You see the 90-degree triangle? Okay, so here is 8. Okay, and ON is the one that we need to find first. And then O to D is radius also, right? It's also radius, is 13. Okay, so I'm going to draw that triangle out here. 90 degree. This is 8. This is 13. This is basically OND. So ON is the one that we want to find. After that, we can minus the 5, because this one is 5. Okay, this is 5. The one below, which is your MN, is the whole thing minus the 5. Okay, so to find this ON, we use Pythagoras theorem also. So ON square will be, since we are finding the side, we use hypotenuse square minus the side square. So ON will be square root of 105. Okay, so square root of 105 after you round off will be 10.247 . So to find MN is the short one, MN. So this whole thing we found it already, which is 10.247. We minus the 5. Okay, we minus the 5. We minus this 5 over here. So 10.247 minus 5. So after you round off to 3 significant figure is 5.25 centimeter. So that's the answer for question number. Let's try it to be. Okay. Task is this. Okay, this is easy. Don't worry, it's easy. Okay, so you don't need to copy the questions. Okay, you don't need to copy the questions, but try it 1 and 2 you need to copy. Okay, question 1 until 9 no need. Okay, but the circle need. The circle you need. Okay, circle need to copy. Only the circle. Okay, only the circles here. Okay, I give you a hint first. What you're gonna do? Number 1 is finding chord AB. Okay, so first theorem tells us that if this one is 90 degree from the center going down, it will divide this into half. So to find this chord of AB, you find one part here first and then you plus another one or you times 2. Okay, so what you need to do is you find this first, okay, using Pythagoras theorem. Okay, using Pythagoras theorem to find this and then you times 2. Okay, so this one you use Pythagoras theorem to find MB and then you times 2 to find A until B. Okay, so for part B also the same, this and this same. So you find AM first using Pythagoras and then you times 2. Okay, Pythagoras theorem confirm you know how to do lah. You check the answer behind there to compare with your answer. Okay, number 2A, find the radius. Okay, radius here I will draw it out for you. This is the radius. It's a line. This is a radius line. Okay, C until D is 24, so it divides into half, so this one is 12. So you can find this radius also using Pythagoras theorem. Part B, same thing lah. This one is 6, so divide into half. This is 3 and 3. This one is the radius that you're going to find and you use Pythagoras theorem. Okay, 9A, it's similar to try it 1 just now. Okay, it's similar to try 1. If try 1 you can do, okay, you listen to the instruction, my explanation again and try to do it one more time here again, number 9A. Huh? Find the radius. Okay, radius means it's here lah, OA. This is the radius you're gonna find. Okay, it involves a bit of algebra. Please refer to try it 1 again. Okay, try it 1 will help you to do number 9A here. Okay, and then B is area of OAB, area of this triangle. This triangle is half base height. Your base is basically AB, the length of the AB, the chord AB lah basically, and your height here is OE. Okay, so half time base time height to find the answer. Okay, I give you much hint already. So for today's lesson, lesson 18, what you're gonna do is all the notes, please take picture and send it to me also. Try it 1, try it 2, and then exercise 3.1, number 1, 2, and 9. Okay, this one must copy questions. Number 1 to 9, only copy the circles. Okay, and try to do it by your own. I want you to send in PDF format. PDF, must. Okay, that's all from me today. Bye. Okay, I think a lot of you don't know what is PDF format. Okay, PDF actually stands for portable document format. Okay, it's a file that is actually most commonly used. Okay, even if you go to university or further studies, okay, most of your lecturer will request you to send in PDF file. Okay, why is this PDF file so important? PDF file is actually a good type for documents which consist of text, forms, or even image. Okay, so it's actually all compressed to one file. Okay, even if you send in images and convert it to PDF file, it's all in one file only. Okay, why PDF? Not only because it's more organized, okay, because all the assignments that you send to me, okay, all the files that you send to me through assignment post in Teams, it will all be in OneDrive. So when I open the OneDrive, okay, you look at here, for example, if I open Melvin's one, right? When I open Melvin's document in PDF format, okay, this is in PDF format, I can actually straight away edit, okay, on the spot and mark straight away, okay, without even download it and copy and return and upload it again. It will automatically there, okay, when it's saved, it's there to return to you. But if it's photo format like this, I cannot edit. There's no button for me to edit. I need to download it. So I don't want to do that. Imagine I have to download all of your work one by one and edit one by one and return it back to you one by one through Teams chat. So it's quite hard for me to do that. So why don't you send through PDF format so I can mark it on the spot? Okay, because I find out all this while I have to feedback you through typing, so I cannot really mark it and tell you which is your mistake. Okay, hope you understand. Thank you so much. Bye.